Don't come late. Just pick a different one for now. Okay. All right. So let's just review really quick because this is what's going to come up in these first few here probably. So we've got our reciprocal identities, which is 1 over whatever the reciprocal is. So sine is 1 over cosecant, cosine is 1 over secant, okay, and so on, all right? Then we've got the quotient identities, which is tangent equals sine over cosine, and cotangent equals cosine over sine. And then we've got the Pythagorean identities. I'm not going to read those again, but they're there, okay? Okay, and then we also have these other goofy ones, which are going to come up here in just a minute. We have these cofunction ones where we learned on Friday that sine of 30 and cosine of 60 are the same thing, okay? So as long as I can get these two numbers to add up to 90, their answers are the same. Okay, that's kind of how the cofunctions work. All right, so let's take a look now at example 8. There it is. Okay, so the tangent of 60. All right, so I could think about and set out. So I'm going to try not to use the right triangle. Okay, I'm going to try. That's my default at the end if all else fails. So this is another way to do something that we've done before. Okay. I know that tangent is sine over cosine, right? Sine over cosine. So I'm going to take the sine, which is square root of 3 over 2, and divide it by the cosine, which is 1/2. So we've learned that we take and we flip and we multiply. So what is the tangent of 60? Square root of 3. All right. The sine of 30... Okay, we learned that this is the same as the cosine, and I need to get this number and this number to add up to 90 degrees. So it's the same as cosine of what? 60, right? Because 30 plus 60 equals 90, and that uses those cofunction identities. What is the cosine of 60? 1/2. Okay. All right. This says we've got they want us to find the cosine of 30, which we know is the same as the sine of what? 60. Good. And what is the sine of 60 according to what they gave us? Good. All right. Secant of 60 is the reciprocal of what? Cosine. We know that the cosine of 60 is 1/2. So what's the secant? 2 over 1 or just 2. It works. Okay. All right, let's take a look at the next one. The next one may not be as nice. Next one, I think we're going to have to pull out the right triangle. All right, that is another Greek letter. Do we know what it is? Alpha. That is alpha. Okay. Another one that comes up, but not necessarily yet. This one here is beta. Okay, so those two are going to start, you're going to start seeing those instead of thetas. They'll put alpha and beta in sometimes. Okay. All right, let's do what I'm not sure if there is anything we actually know. Well, there's one. Can't we do this one here? If the tangent is 3 over 2, what's the cotangent? 2 over 3. They didn't give me a degree this time, did they? Okay, so I'm going to have to work with the right triangle. There's no other way to do it other than with the right triangle if I don't have the degree measure. Okay, and they didn't give me really anything else to go with here. So I'm going to draw my right triangle. I'm going to put an alpha in there. I don't know why I drew it that way versus the way the other way, but I did. All right, tangent is what over what in SOHCAHTOA world? Go ahead. So my opposite is 3. My adjacent is 2. How do we get the hypotenuse? Good old Pythagorean theorem. So 2 squared plus 3 squared equals x squared. What's 2 squared? 3 squared. 9. So x squared is 13. Take the square root of both sides. So I get square root of 13 on that hypotenuse. All right. Using the right triangle now, what is the secant of it? Secant is SHA. So what's the secant of it? 13 over 2. Good. Okay, using your right triangle again, what would we get for this sign? 3 over square root of 13, which we don't like, we would rationalize it, right? So it'd be 3 square root of 13 over 13. Okay, now this is that cofunction identity, and we can almost read it right out of the sign, right? So sine of 90 minus alpha would be the same as the cosine of alpha. So this is a fancy way for asking us to find the cosine of that triangle. So I could either use the triangle, or could I flip this? Yeah, your choice. This is going to get you the same thing, to 2 square root of over square root of 13. So we rationalize it. So we got 2 square root of 13 over 13. All right. Now we're going to play with some identities a little bit. Okay. We spend a lot of time, especially when we get out of chapter 4 and we get into chapter 5, doing stuff like this. And some people absolutely love it and some people absolutely hate it. Okay, I think it's kind of fun once you kind of get into it and you start seeing the pieces of the puzzle come together. Okay. Basically what I have to do is I have to try to take this side and turn it into a 1. Okay, so a lot of times we'll call this verifying the identity. All right. So I'm going to rename one of them. I know that secant could be substituted in with 1 over cosine, can't it? Because it's the reciprocal of cosine. What now happens with my cosines?
Cancel out.
They cancel out. And what am I left with?
1.
Is that what I wanted to get?
Yeah.
Yep. So here's when we grade a problem like this, the answer isn't 1. The answer is this work in between. Okay, we would want to see you substituting the 1 over cosine in, which means I'm looking at the work that you wrote on your paper, not something necessarily in your, whatchamacallit, on your Chromebook. Sometimes we do a fill-in-the-blank kind of thing, like you did fill-in-the-blank proofs, probably in geometry. Okay. All right, let's look at this one. This one's a little bit uglier. All right. All that algebra we did at the beginning of the year, the foiling and the factoring, we can do all that with trig. Okay? So, we're going to foil with trig. Doesn't that sound like fun? Okay? All right, so, what is secant times secant? Secant squared theta. All right, secant times negative tangent would be negative secant theta, tangent theta. Tangent times secant would be, yeah, I'm going to go secant theta, tangent theta, but either way works. Okay? All right, yes, they're going to. All right, tangent times negative tangent is going to be negative tangent squared theta. It doesn't matter that it says secant and tangent versus x and y. Okay? It works the exact same way. All right, and again, we're supposed to be showing that it equals 1, so we're not going to write the 1 part down. What's going to happen with these two terms? Weren't they conjugates of each other? Did I really even need to do that part? I really only needed to do O and I. Okay? Alright, so secant squared theta minus tangent squared theta. Alright, so if there's 2 ways I could think about this one. I want you to look up at the windows. So pick your side and look at the window. I want you to look at the middle window right now. Okay? The middle row. So everybody see the middle row? So that's our row that shows the relationship between secant squared and tangent squared, right? So I could replace secant squared. I could take this part and I could put 1 plus tangent squared into it, couldn't I? Minus tangent squared, and these guys cancel and I get 1. But look at the middle sign. Doesn't it say secant squared minus tangent squared equals 1? So the other way, this is one way I could have done the work. The other way I could have done the work is I could have just written down a 1. Okay? Are both of them okay ways to do it? Absolutely. All right? So, but I used that middle row. And that's why I have the middle row. It's the way it is, because I solved all the possibilities for you. Okay? So you can kind of look up there and go, oh, yeah, that means the same thing. Okay? But if you don't have the solved one, it's very easy to sub in and just cancel. Okay? Did we show the one that we wanted to show? Yeah, we got to the 1. But again, it's the work in between is what we would be grading. Okay. All right, let's try. What's wrong?
Wait, what is the u equal theta?
It just didn't. Yeah, whatever your variable is, theta, or x, or alpha, or whatever it is. They just they tend to show it when they're showing you the formula or the identities. They tend to put a u there. We see the same thing in our calc book. It happens to be this author does that a lot. Okay, so here's what I'm going to do next. I have to try to turn cotangent squared into 1 over sine squared minus 1. Okay? So the first thing I'm going to do is I'm going to get this into sines and cosines. So I'm going to replace cotangent squared with cosine squared over sine squared. So it doesn't matter if I've got a squared or a cubed or nothing on it. I can still do the cosine over the sine. Okay? Now, it's only in sines. So I'm going to keep the sine in the denominator. And I'm going to choose, the only thing I know about cosine squared is the Pythagorean identity. So I want you to look at the middle window in that first row and read what cosine squared is equal to and tell me what it says. Good job. 1 minus sine squared. So let me show you what happened. Okay? So we took this and we knew it was equivalent and we substituted in the 1 minus sine squared. All it is we're doing substitution in. Okay? Now, I have to turn this into this thing here. Okay? I am going to choose, I lost a square, didn't I? Should be sine squared in the denominator. All right. I'm going to split that into 2 separate fractions. So I'm splitting into the fraction of 1 over sine, so this is just algebra, squared theta, minus sine squared theta over sine squared theta. What's sine squared over sine squared?
1.
1. Isn't it like magic how these things just pop out? And did we get what we wanted? Yeah. Trig is all about, when we say trig, this is what they're talking about. They're not talking about right triangles. Okay? When your parents they glaze over and they said that trig was a nightmare, this is the stuff they're talking about. There's stuff that's this is pretty easy. There's stuff that's uglier than this eventually. Okay? It's coming. We know we're going to make it as painless as possible, right? But it's because you can take something and you can convert it into something else. That's why I think it's fun, because it's kind of like a puzzle, and I got to figure out how I get from point A to point B. Okay? All right. The next one we get to use our calculator. Yay. Okay? We're supposed to evaluate the function. I'm going to let you try this, because I don't have my calculator up and running yet. Which mode should your calculator be in? Look at what it says. It says 14 degrees. So which mode? Degrees. So everybody you remember how to put your calculator in degree mode? Hit the home button, the settings, right? Dock settings, make sure the angle says degree, hit make default, and hit OK. Then go to your scratch pad and find 14 degrees. Oh, it looks like I need to. Let me see. While you're doing that, first one, let me see if I can get the calculator going so we can review a little bit. All right, did we get a number? Yeah. What did you guys get for your number? Point what? 1972. 4 decimals are fine, right? As long as it's at least 3, you'd be able to find a multiple choice answer, right? Okay. The next one. Do you remember how to get the minutes? All right, so type in your cosecant. Hit that first. All right. And then you want to hit your catalog, the little book button, right? And I believe it's on the 3rd tab. Is that right? Make sure I'm right, because I don't have mine going. And if you scroll down, oh, here it is. Okay. First of all, I got to check my mode, because I'm pretty sure I'm in radians. Home, close. Home, settings, dock settings. Yep, I'm in radians. Go to degrees, make default. Okay. All right, so to do so now I'm going to go to my scratch pad. And I'm going to get my cosecant in there. Alright, and then I want to go to my book button. And, oh, it's not the third tab, it's the second tab. Second tab at the top gets us, if you go down to where it says degrees, minutes, seconds, and I click on that, it sets it up for me. And it said it was supposed to be 18 degrees. And, oops, 51 minutes. And hit enter. I was looking at the tests, and there is one that's similar to that. Okay? So 3.0951. 3.0951, right? Okay, the next one says that we're looking for pi, cotangent of pi over 12. So what mode should our calculator be in? Radians. You're going to have to do this on the test where you switch modes. Okay? I will not be able to help you. So make sure you know what you're doing. So go to your home settings, dock settings, and go to angle mode, radians, and make default, and click OK, so it changes on your scratch pad. Radians. Did mine say gradians? Radians. A gradient is another measurement they use in science. Yeah. Alright, and this one said cotangent of pi over 12, so I'm going to go to my little button here and hit cotangent. And then I'm going to hit control divide. And it's not going to be one that's on your unit circle if I want you to use the calculator, right? If it was on the unit circle, we just type in the unit circle answer. Pi over 12. Remember, pi is over here. Okay, and hit enter. 3.732. Does that sound good? Rounded 3 places correctly? Nope, not that button. This button. Alright, 3.732. Okay. So the next few are asking us to find the value of theta in degrees and radians without using the calculator. So do you guys have your unit circles out? Get your unit circles out. I'll give you 30 seconds to do that. Those are your new best friends, right?
I lost my best friend. And who wasn't your best
You get to use it on the test, dude.
friend? Doesn't want to be.
How could you lose your best friend?
I don't have.
That's sad.
It is his best friend. It is some best friend you are.
Alright. So what we're going to do is we're going to find each value in degrees and radians without using the calculator. This should be pretty easy to do. I'm going to choose to use the coordinates, okay? So I'll do it with the coordinates and then I'll do it with the triangles, okay? Notice, what quadrant does this say that we're in? What does that mean right there? We're in the first quadrant, right? 0 to 90 or pi over 2 is just quadrant 1. Is cosine the x value or the y value? It's the x, right? It's always cosine comma sine. So I need to find in the first quadrant where the x value is 1/2. So I know that this is 0. Oh, sorry, it's 1, 0, isn't it? So it goes 1, 2, 3, 1, 2, 3. So it's right here, isn't it? What's the radian measure right there? Pi over what? 3, good. And then the degree measure is what? 60. Okay. Yep, that's it. I would use the coordinates. I think the triangles would be too hard, wouldn't it? I guess you could go to your two blue triangles, right? Or your blue triangle and your green triangle. And you're looking for where the adjacent is 1 and the hypotenuse is 2. So I guess you could probably see that off your 60, right? Your green triangle. Where the adjacent is 1 and the hypotenuse is 2. I think it's easier with the coordinate. Alright, let's look at the next one. Oh, look at how nice that one is. Alright, so again, we're still in quadrant 1. Okay, so we're only working in this quadrant. Is the sign the x value or the y value? The y value. So you need to look for where your y value is square root of 2 over 2. It should be the one right in the middle. So what's the radian measure first? Good. And then what is the degree measure? 45. Perfect. Which you could have also probably figured out from your triangles, but much harder because it's rationalized, right? And the triangles aren't rationalized like the coordinates are. All right. You guys, make sure you know how to do that. That comes up quite a bit. We use that in calc a lot. Okay? All right. I think we've written these down like 4 times, haven't we? Do you still have... Is it typed there for you, or does it want you to... Or is it even there? It's not even there. Okay, reference back to what we did before, right? So hypotenuse equals short times 2, long equals short times square root of 3, hypotenuse equals the leg times square root of 2. We've seen it a bunch of times, okay? So we're going to find the exact value, right? Again, this is review, okay? Let's see. What's on your short leg right now? 30 is the angle. What's on the short leg? Y. So this is your short, which means 100 has to be the long and R has to be the hypotenuse. Okay, so if I'm going to solve, I can't solve for the hypotenuse until I've solved for the short. So I'm going to have to use my long leg formula. So long equals short times what? Square root of 3. All right, so what is on the long leg right now? 100. Okay, the short leg I don't know right now. It has a y. Okay, and then times square root of 3. How do I solve for y? Good. We're going to divide by square root of 3. We probably would rationalize that. So 100 square root of 3 over 3. All right. And now I need to find the hypotenuse. So we know that the hypotenuse formula is hypotenuse equals the short times 2. What's on the hypotenuse right now? R. And then the short is this 100 square root of 3 over 3 times 2. So I multiply the 100 and the 2 together. So what's 100 times 2? 200 square root of 3 over 3. The reason they're using the R is because of the unit circle. Remember, it's the radius part of the triangle. That's why it's an R instead of something else. All right, let's look at 19. Okay, so this one is a 45, 45, 90. What do we know about the legs of a 45, 45, 90? They're the same, so I know my x is 2 square root of 3. In order to get my hypotenuse, I take the leg and I multiply by what? Yeah, and this is where you can tell this was coming out of the pre-calc book versus the Algebra 2 book, because they put a radical that wasn't a square root of 2 on it. All right, so we've got the hypotenuse is r, my leg is 2 square root of 3, and I'm multiplying by, not by square root of 3, by square root of 2. Don't write square root of 3 down. Square root of 2. All right, so with radicals, remember, whatever's underneath gets multiplied together, so I get 2 square root of what? 6 is r. This is just the quick review. So we're not going to spend a ton of time on that. All right, looks like we've got 3 more, and we're going to do angle of elevation, angle of depression again, right? This one you had to watch on the video. Today you get to watch me draw the pictures live. It's even better, right? I'm terrible at drawing pictures. It's amazing they let me at one point teach multimedia, and I cannot draw. No art skills whatsoever. Yeah, I know. But you gotta be, in math, you gotta draw pictures, right? So, sometimes. Alright, a surveyor is standing 50 feet from the base of a large tree. So we've got our surveyor, okay? And we've got our large tree. There we go. The surveyor is almost like a third of the size of the tree, too. Isn't that great? Alright. The surveyor measures the angle of elevation to the top of the tree is 71.5 degrees. So to make this better, our math easier, we're going to pretend he measures from the bottom of his foot. Okay? Because if not, it makes the math too hard. Alright? So it says the angle of elevation, remember, angle of elevation is the angle looking up, so 71.5 degrees. It says he's standing 50 feet, so I would label that in the triangle. Remember, the whole idea is to try to find your triangle. And then it wants to know how tall the tree is, so the X would be right there. So does everybody see your triangle in there? Hopefully pretty easily. Right? The idea is find the right triangle. Alright, so now you have to decide if you're using sine, cosine, or tangent. So which one what do I have? Opposite and adjacent, so that's TOA, isn't it?
Yeah.
So tangent of, what do I write down?
71.5.
Good, and it's degrees equals what?
50.
X over 50. Alright, we're gonna need, well, we're almost at the calculator. What do I need to do to move this to the other side? Multiply. So 50 times tangent of 71.5 degrees equals X. We just put your calculator into radians, didn't we? So go back and fix the degree mode. Okay. So fix it back to degree mode. And then I'm going to let you put in 50 times the tangent of 71.5. So I'm going to give everybody a minute to do that. Don't shout out the answer yet. So fix it and get the and type in your answer. Get decimal 3 places. Shh. It's obviously not 12.
Did I say 12? I meant the right answer.
Okay. All right, what did we get? 0.434 feet. Make sure you label it with feet, right? Because it is technically a word problem. I'm not making you write a sentence, but at least we could label it. All right. All right, let's check out the next problem. So you are 200 yards from a river. Okay, so draw a picture of yourself, self-portrait. It's Mrs. Ballard. She never wears dresses. There's my long hair. Oh, I wish I had curly hair. I don't have curly hair. All right. All right, then it says, you're standing 200 yards from a river. So here's my river. My river is blue. All right, there's my river. It's a good river. All right, and then I need to find my triangle here. What? Sharks don't live in rivers. All right, so you are 200 yards from, rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. So rather than doing this, you decide you're going to do this. Okay, and this says that it is 400 yards. All right, find the acute angle. Oh, so you are 200 yards, so this is 200 yards. So instead you decided to walk more steps, right? You're trying to get your steps in today, apparently. All right. Find the acute angle between its path and the river's edge. So you're trying to look for this. Okay. All right. So it looks like I've got the adjacent and the hypotenuse. So isn't that All right. So I've got that's cosine of theta equals. So what would I put over what? 200 over 400. All right. In order to simplify cosine, I would have to, actually, I know that reduces to 1/2, doesn't it? So in order to get rid of cosine, I do the cosine inverse, or the arc cosine of both sides. I could use my calculator for that, because these guys would cancel. So let's put that in. I'll do it with you. Okay, although my calculator's in the wrong mode. It should still be in degree. Okay. So I'm gonna go, I gotta get my mode fixed. Settings and status, stock settings. Degree. Okay. So we're gonna go cosine inverse of 1/2. Everybody gets 60 degrees? That one there, because we recognize it, you could have probably used your unit circle for. Okay? Alright. Okay, so we're supposed to find the length C of a skateboard ramp with a height of 4 feet and angle of elevation of 18.4. Okay, so we need a skateboard ramp. So that means we need a skateboarder. There we go. Oh, skateboarders wear hats, don't they?
Helmets.
Oh, is that? Yeah, I don't have I can't draw a helmet. There's no way. Or should be wearing helmets. My children will not be getting skateboards.
I still don't know how to ride one.
You still don't know how to ride one, Ivan?
No.
Do you have one?
No.
Okay, see, there you go. It's okay. They can live without a skateboard. Alright. Height of 4 feet. And angle of elevation, so the angle up is 18.4 degrees. Alright. So it looks like they want us to find this value right here. They're calling that value C, right? That's what they said in the problem. It looks like I've got the opposite and the hypotenuse. So what's opposite and hypotenuse? Sine. Could I use cosecant? I could. So you could really use either one. Alright? So the sine of 18.4 degrees equals my 4 over my C. Okay, so what am I going to have to do to get rid of the C? Multiply. So C sine of 18.4 equals 4. And then how do I get this sine of 18.4 to the other side? Divide. Okay, so before you punch the buttons, let me show you something real quick. Okay? Let's say I had done cosecant instead.
Yeah.
So if I had done cosecant, that means I take my hypotenuse, C, and I divide by 4, don't I? So look at how it is fewer steps, right? So instead of writing 3 lines of work, I've got 2 lines of work, right? It's just a different way to look at it. Okay, so either one you're going to get the same answer. Okay, so go ahead and punch the buttons. I don't care which one you use. Alright, what do we got? Yep, it doesn't matter which one. 12.672. And this would be feet again, right? Did I label the last one as yards? I should have. Oh no, it was degrees. Never mind, we're good. Alright. So, I have sort of good news for you. We were going to take a test on Thursday. Miss Dudley and I are not going to be here on Wednesday. So we're going to have to take the test on Friday. So we're pushing it back a day, which is kind of good news. The downside is Friday we have an assembly. Which, it really doesn't affect your class, right? Your first and second period, you should, and hopefully you're not setting up for the assembly at that point. The other downside is that is the absolute last day of the triad. So, if you're not here for the test and you don't make it up really fast on Monday, you might get a big fat 0 in there. So, no, we're going to do a test. Alright. Okay, so just so you know, it's coming on Friday. We're gonna start reviewing tomorrow. Okay? So we're gonna do some study guide review tomorrow. Wednesday we'll have some kind of activity for you. Thursday we'll go over the study guide stuff. Okay?
Our notes due?
Yes, notes will be due on Friday as well. Okay? Friday's the end of the triad. Any homework or performance tasks that are outstanding are due. I did put in, for most of you, the last test. Okay? There's one that I think I left the paper here, and there's 1 or 2 people who haven't taken. So I'm not passing it back yet, but I will eventually. Most of you did really, really well on the last one. Okay? So, good job. Okay, it looks like I've got a few minutes. Do you want me to come around and stamp? Or do we want me to wait till tomorrow? Okay, I will come tomorrow to stamp, apparently. Okay.